All right, everybody, we just got it okay to start the final planetarium show of the day. So, welcome, everybody, to the Morrison Planetarium. My name is Christian. I want to be your planetarium presenter. And let me change the vibe in the room real quick. Let me change the lighting in here. And again, my name is Christian. I'm going to be your planetarium presenter. And I'm not just a voice coming out of the walls, I'm actually a person, and I'm standing right behind you at the very top of the planetarium. Hey, good afternoon, everybody. Good to see you. Don't hurt your necks. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow all throughout the room. And folks, I'm really happy to have you here today because we're about to do my favorite planetarium show. This one's called Tour of the Universe. This show is completely live, so you're going to hear my voice for the next 30 minutes as I free fly us through space. And we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. But before we get started with the show, I got to go over some quick house rules just so that we're all on the same page and have a good time. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away till the end of the show. We want to keep this planetarium as clean as possible. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light, now's a good time to put those devices away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And if you need to leave early, the exits are always going to be at the very top of the planetarium, so always make your way up the stairs to exit. If the staircase is too steep for you to climb, do not worry, just remain seated. Once the show is over, we'll have a staff member escort you to a lower exit when the show finishes, so just stay seated for a bit longer. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths. Then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling all the way to the edge of the observable universe. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let us begin our tour of the universe. And I've just regained the controls here. And folks, we're going to be starting off pretty close to the Earth. We can see all the city lights just down below, but we're going to be starting off at this spacecraft just a little bit above it. What we're looking at is the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I always hear about it in the news and articles, but I don't really know what it is. Could you explain it for us? Well, of course, folks. The International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct so many different types of science experiments all the way up here far from the surface of our planet. Some of the things that they'll test out are things like what happens when you try to grow plants in space? Which way do the roots grow? Another one that they've tried out is what happens when you spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. And after that year, they compare and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have as much gravity working down your muscles constantly. So if you plan to live in space for a long, extended period of time, remember to exercise daily. And also, folks, this spacecraft looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire museum we're sitting in. That's roughly how big it is. And also, what's really impressive is that the ISS is traveling incredibly fast. It's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this looks really far away from our planet, but it's not too far either. It's only about 250 miles above the surface of our world. 250 miles, that's not too bad. That's like going from San Francisco to Santa Barbara, a nice little road trip with the family to get away for the weekend. So, not too bad. But to tell you the truth, folks, 250 miles is as far as we put humans into space nowadays. The reason why is because it's quite costly traveling all the way out here. You got to build yourself a rocket ship, buy yourself one, or pay for a ride. And then once you acquire that, you have to account for all the rocket fuel you got to be able to escape the Earth's gravity. And then once you acquire all of that, you also account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly disappear to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it starts to slowly fade away. And now, folks, from all the way out here, we're now able to see our entire planet Earth. And I want to let you know that the space program that we're using here inside the planetarium is something that you can go home and download if you want to fly through space, just like how I'm doing. The space program that we're using in here is called OpenSpace. So if you go to openspaceproject.com, you can come across the link where you can download this, and it's a whole lot of fun. Also, this is an open source software. That means anybody can add to it. So if you know computer programming, you can add spacecraft models, you can add planets if you like. So it's a whole lot of fun. Highly recommend checking it out. And also, this is in its beta phase. It's not completely finished. So we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully, we'll look past them. And also, OpenSpace uses a whole lot of processing power. So if you have an older computer, you may not want to download it. But if you got something new or a gaming computer, give it a try. It's a whole lot of fun. And if you're a person like me that doesn't want to download anything, we also have another great alternative called NASA's Eyes. So just like the human eyeball, go to your favorite search engine, type in NASA's Eyes. Don't have to download anything, and you can fly through space, and it's so much fun. But in here, we're using OpenSpace. But now that we got a sense of what we're using, let's make our way over to our nearest natural neighbor to us in space, the moon. And we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we'll be doing that. And what's really amazing is that with Artemis, they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and that's going to be very helpful because we can melt that ice, pass electricity through it, separate the hydrogen and oxygen, and both that stuff's very valuable when you're far away from home. So again, look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, when we look up at the moon here from planet Earth, especially tonight, because tonight is a super moon, moon rises here in San Francisco at 8 o'clock. If you watch the moon rising on the horizon, it's going to appear really, really big. So highly recommend checking it out. And sometimes when we're looking at the moon, it feels like you can reach out your arms and touch it. But the moon's incredibly far away, folks. It's about 240,000 miles away from our planet Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop going about 80 miles per hour. Although we wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds at the speed of light to cross that distance. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. So cute. And just like how we saw before, folks, we're now going to see the moon as it starts to slowly fade away into the darkness of space. And before we lose track of the moon, I want to add some nice planet trails so we can keep track of it as we start to slowly see it disappear as well. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view. So here comes the sun. Do, 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 do. And the sun is also incredibly far away from us here on planet Earth. It's about 93 million miles. Whew, that is a good distance away. Now, at the speed of light, it only takes sunlight about the 8.5 minutes to cross that 93 million miles. So very, very fast. And this is a really good concept, folks, because again, it takes sunlight about 8.5 minutes to travel all the way to Earth at 93 million miles. And this is important because when we want to learn about objects that are really far away in space, it takes time for that light to reach us. So let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light reached us, took 70 years to get to us. So when we look at really far away objects in space, it's like looking back in time in a sense, which is really cool. But now that we got a good, nice bird's eye view of our solar system, let's do a quick refresher of what we have. In the middle of our solar system, we have our star, the sun. Closest planet to the sun, we have Mercury. Then we have Venus. It's really hot there. And then Earth. That's us. And then we also have the famous red planet, Mars, just on the right-hand side. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have our asteroid belt. This is where you're going to find about 1 million asteroids, give or take. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Saturn, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, just on the very top right side of our screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, that's a lot of stuff. And the Kuiper Belt is like a second asteroid belt past the orbit of Neptune. What you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And what's really impressive is that in 2006, our technology greatly improved. So we're able to see much smaller objects much further away. And we found more than 400 objects out here in the Kuiper Belt region in 2006, and some of this stuff was bigger than Pluto. We couldn't call all these things planets. There was just way too many of them. So all the astronomers on planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And they came up with 3 criteria, folks, and that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And I know a lot of folks have a lot of hard feelings about Pluto becoming a dwarf planet, but that's the really cool thing about science, because as our technology improves, we're able to make better observations. And so we're able to reclassify things that we didn't know before. So science is constantly updating and changing, and I find that really fascinating. But I'm going to put away the Kuiper Belt for now, because that's just a whole lot to look at. And now I'm going to be adding on screen the many different spacecrafts we sent out in the solar system in the 1970s to explore it. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest in them all, New Horizons, which did a quick flyby of Pluto in 2015. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours to get all the way out here. Not too bad. But now, folks, it's time for us to leave our planetary scale behind us because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us roughly about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri is going to be the star on the very top right that's moving closest to us. So again, we're right in the center of our screen. Alpha Centauri is going to be the top right, that star right over there. 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't put into perspective of how long it would take us to physically travel there. Well, if you're to get in a rocket ship of today's capability, make your way over to Alpha Centauri. It's going to take you roughly about 8,500 years to make that journey. Whew. And that's just a one-way trip. But folks, let's stop consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. And again, folks, we're now inside something called the radiosphere. This represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into outer space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signals, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before the early 1930s, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have space telescopes where the whole purpose is to find as many exoplanets as possible. In fact, as we start to swing around, you can look at the very top of our screen, and you can see we found a whole heap of exoplanets in that one direction. We pointed our telescopes in that direction for about 10 years. So as they continue to scan more and more of the night sky, that 5,000 number will be increasing. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed, created in the moment, so we got a few years before those are ready and launched into space. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, well, the communication delays between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet. But eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. All right, folks, we're now looking down on our Milky Way Galaxy. This is the galaxy we live in, and I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way Galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you roughly about 130,000 years at the speed of light. It is really big. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If a recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from the side. You're going to notice that we live in a big flat spiral disk. Kind of looks like a giant pancake in space or a frisbee. And this is important because when scientists and researchers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way galaxy, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. And folks, the Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture continues to expand, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they create voids where there's very few galaxies or no galaxies at all. So we can see a nice galaxy clustering towards the center of our screen. We can see very few or no galaxies to the top left of our screen. So you can think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're looking at right now represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tully, who works at the University of Hawaii, who compiled this amazing representation over decades of time with many astronomers working aside him. So big shout out to Dr. Brent Tully. I love flying through this galactic map. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And as we start to swing around, you're now going to realize that the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of the Milky Way? Well, if we were to line up our Milky Way galaxy, it would line up just down the middle vertically, just like so, up and down. And again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way. Well, researchers still want to make sure that they can still find galaxies, so they have this purple survey of galaxies. You'll notice that they were still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. And speaking of time, we're almost out of it. So let's continue pressing on, folks, because now we're going to be encountering these really distant, far away objects known as the quasars. And the quasars are going to be represented by orange dots on either side of the large-scale structure of the universe. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, before stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. What we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large scale structure of the universe, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But, folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And, folks, let us make our return trip back to planet Earth. All right, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. I also want to remind you folks with that thought that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of the night sky. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way Galaxy. We're heading straight for that radiosphere. And of course, we're making our way to our little neighborhood, our star system, our solar system in the vastness of space. And now, folks, we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt region, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And if you want to show, this exact show with somebody that was unable to make it today, friends or family, this show was actually live streamed and it's saved onto the Morrison Planetarium's Facebook page or the California Academy of Sciences YouTube page. So you're more than welcome to share this exact show with your friends and family who are unable to make it today. But hey, look at that. We made it back home safe and sound just in time for dinner time, folks. And that's all the time that we have for today. Thank you so much for stopping by. And we hope you all have a wonderful rest of your day and make sure to get home safely.